All right, welcome to new material for week 2, June 29th to July 5th. We're on new 10, NEW, and we are starting systems. Graphing we're going to start with, and this is the general progression with this. We're going to start with systems that are systems that are solved for y, and the reason why you start with systems that are already solved for y, we started last week reviewing solving for y. So if you remember, this is when you practiced taking an equation and getting y by itself. So putting equations in slope-intercept form, or solving in terms of y equals mx plus b, right? So when you solve systems, we start with graphing. It's not necessarily the most versatile because in order to do this, you would need graph paper. You don't always have graph paper with you. You don't always have them solve for y. There's just a lot of things that would have to kind of line up. Your stars would have to align in order for this to work. And that doesn't always happen. But there are some times where you would want to use this. And one of the biggest or most useful times is when you would want like a visual aid. So when you're going to want, to see when a problem would have, like when you're throwing a ball up in the air, or when you want to see where two things have a common point, that's when you're going to want to do something like this. So that said, let's do some of these. There are, a couple note type things with this section. Oh, excuse me. Yawning. And let's see how we do this. For those of you who asked last week, and I know when our live abruptly ended, it came up a little bit of confusion on how to graph the M and the B. This is the section we'll see it in. Hopefully this will clarify it a little bit, and if it doesn't, we'll make sure we go over it. All right, so steps for solving a linear system using graphing. So we want to first put the equations in slope intercept form, which is y equals mx plus b. All right, we want to graph each equation on the rectangular coordinate system. Okay, we want to locate the point of intersection. All right, so where the two lines meet, and write it down. And then we want to verify that the ordered pair all right, that's going to be our x comma y, makes both of those equations true. All right, so let's remember what is an ordered pair, and kind of what we're doing with this. we have to remember that we have to even talk about what a system is. Let's just back this train up. All right, this whole chapter, what we're working with, is called systems because what a system is two equations, okay? So this right here is a system. It's called a systems of equations. You'll notice that now, I mean, last chapter we dealt a little bit with two variables, but we never had to solve for both variables, right? We picked an x and then we had to solve for y, or we picked a y and then we had to solve for x. If you want to solve for both variables, we have to have two equations. So the number of variables you have requires that many equations. So if you want to solve for 5 variables, you would need 5 equations. If you wanted to solve for 12 variables, you would need 12 equations. If you want to solve for 1 variable, you need 1 equation. So here we're going to focus on 2 variables, x and y, which means we need 2 equations. This is why we're working on the rectangular coordinate plane or the Cartesian coordinate plane, which has the x-axis and the y-axis. The x-axis is left-right and the y-axis is up-down. Therefore, our answer will always have an x and a y. So in order for it to be a solution, it not only has to work for the x, but it also has to work for the y. Okay? So we've practiced substituting into one equation. But let's now tell whether the ordered pair is a solution to the linear system. So we want to know if this ordered pair here, 0, -4, is a solution to the system. So we're going to test it out for both. So we're going to create our little template for parentheses minus parentheses equals 10. And then I'm going to set my other one up. Parentheses minus 5 parentheses equals 20. I'm going to draw a line between the two because one's my first equation, my second's my second equation. All right. Now, that's my x in the first one. That's my x in the second one. That's my y in the first one. That's my y in the second one. Okay, here's my x. Here's my y. All right, so 0, 0 goes everywhere I see an x. -4 goes everywhere I see a y. All right, so now I have 0 plus 4, because notice that double negative gives me a plus, okay? And right away, I can tell that 4 does not equal 10 here. Now, as soon as this does not work for one of my equations of my 2, it is not a solution for my system. Because in order for it to be a solution for my system, this ordered pair has to work for both. And right away I see that it does not work for this first one. So I don't even need to go to my second one. I don't even need to test it for my second one. Because my answer is no. This ordered pair is not a solution. Okay? So no, it's not a solution. Now, if I came over here and I say 0, look, -5 times -4 is plus 20 equals 20, 20 equals 20. Yes, this one is a solution over here. This one works, but this one doesn't. Okay? This is a no, which forces this whole thing to be a no, because it does not work. This is like, I have 3 kids. In order for us to pick a movie for family movie night, everyone needs to agree. Okay, just because, one of my kids wants to watch Star Wars doesn't mean we're all watching Star Wars. All right, so that's that. Now, getting to the meat of this. In order to graph, and here's where the M and the B stuff comes into play. I need to identify my M and my B. Now, if you remember, Y equals MX plus B. B was where I began. It was my y-intercept. It happened on my y-axis, and it was an up or a down move, right? M was my rise over my run. So if we look at this first graph, I'm going to do it all in, let's do green. We'll stick with green. Okay. This means I'm going up 5. And if I look, what's my fraction before the x? It's -1 over 1. So I'm going down 1, right 1. Okay? Now, while we're writing this out, let's do the other one. Okay, I'll do this one in red. Let's pick a different color because I did a lot of writing in red. Let's do purple. Okay. This says I'm up 1. And there's nothing in front of my x, which means I'm 1 over 1, which means I'm up 1, right 1. Now, if you're saying, how did I get this? My default is up and to the right, because that's positive, right? Default is up and right because that's positive and positive. So that's why right here I went down because that was a negative. So now let's graph. We're going to start here. We're going to graph this one first. This said I went up 5, and I always begin with my B. So I'm going to go up 5. 1, 2, 3, 4, 5. And I mark a dot. Then I'm going down 1, right 1. And remember, anytime I'm marking slope or I'm marking a point. I have two moves, and then I mark another point. So I go down one, right one, and then I mark a point. Down one, right one, and then I mark a point. Down one, right one, and I mark a point. Down one, right one, I mark a point. Down one, right one, I mark a point. Down one, right one, and I'm just marking as many points as I can. Okay? Now, I can connect them with a line, but ultimately, I want to see the dots. The line's not going to help me as much. The dots are. Now, let's do our purple line. I want to start with my B, which is this up 1. My B. Oop. Sorry, I hit my eraser. Okay, my B right here. So I'm marking it up 1 right here. It's an up or down move on my y-axis. Here's my y-axis. And then I'm doing my slope, which is right here. Up 1, right 1. From my B, from my up 1. I'm going up 1, right 1. So I go up 1, right 1. Up 1, right 1. Up 1, right 1. And you see I can continue on, but I don't really need to because I'm looking for the point that was common. I'm looking for the point that was an overlap. And the point that was, the point that they overlapped was this one that I just put a square around, was right here. And that point, the ordered pair of that point was, you want the X and the Y, the ordered pair of it, and it was out 2, up 1, 2, 3. And remember, that is the XY. So how many over? 1, 2. How many up? 1, 2, 3. So my ordered pair is 2, 3. All right, let's go to the next one. All right, so let's highlight this in green. We'll do this one in green. All right, so let's talk about it. Here is my B. This is where I begin. So I'm up 7. This is my slope. So this is up 3, right 4. So if I graph this one, I'm going up 7. 1, 2, 3, 4, 5, 6, 7. Now, I can't go up 3. So I have to go down 3. Well, if I go down 3, this is the opposite, right? So what's the opposite of right 4? Then it's left 4, right? So the opposite of up 3 would be down 3. The opposite of right 4 would be left 4. So if I go down 3, 1, 2, 3, then I have to go left 4. 1, 2, 3, 4. See if you can fit another point. Okay, if you can't, you can't. That's, oh well, okay. So 1, 2, 3, 1, 2, 3. Okay, I can't, so I'm done. Now let's do the other one. Here's my other one. This is my B. So I'm up 2. Here's my slope. So my slope is, now see how my negative is out in front? I want to either attach it to my up or my down, but not both. So I'm going to make it down 1, right 2. All right, so I'm going to go up 2. I'm going to go down 1, right 2. Down 1, right 2. Now see how I'm getting farther away from where my lines would cross each other? Like going this way is not helping me. So I can go the other way too. Instead of going down 2 or down 1, I can go up 1. But instead of going right 2, I have to go left 2. So if I go up 1, I have to go left 2. And again, I go up 1, I go left 2. There's that dot that they match. Okay, now that I found it, again, I want that ordered pair. And I have to count my X and my Y. So how many over? -1, -2, -3, -4. How many up? 1, 2, 3, 4. So my ordered pair answer is -4, +4. And I'm all done. All right. Let's look at this one. Green graph. My y-intercept, my B, I'm going up 2. My slope is 2 over 3. My rise over my run. So I'm going up 2, right 3. So I'm starting at 2, and then I'm going up 2, over 3. Up 2, over 3. My other one, I'm starting up 6. My B is up 6. And then my slope, again, that negative is popped out. I'm going to pop it up. And it's going to be down 2, right 3. So I'm going to go up to 6, and I'm going to mark my point. And then I'm going to go down 2, right 3. And I get that common point right there on the first try. If I wanted another point, I could go one more. Because again, when you're connecting these lines, you see what you get here. You actually have these nice 2 long lines like you would have in week 1. We get these nice 2 long lines. Now you just have 2 lines graphed together. But really what we're looking for is that common intersection point. And we're looking for that ordered pair answer, that X comma Y. And that X comma Y here is 1, 2, 3. 1, 2, 3, 4. So 3, 4. And we're done. Practice graphing. Practice using that M and that B. Practice finding that common point, that intersection point. Let me know how it goes. And I'll see you back here.